Hare Krishna. Hope you are doing well. Let's get started with this question. And if you look at it, it will scream central limit theorem. You are given a sequence of IID binomial or Bernoulli variables, and there are two statements regarding the convergence of distribution, and you have to say which one is correct. We'll see it uses central limit theorem, obviously, and Slutsky's theorem as well. Okay, starting with the theory. It's pretty standard that when the distribution is binomial or Bernoulli, then the maximum likelihood estimator of the parameter p is going to be the sample mean. And we see that the setup is IID. The expectation of this maximum likelihood estimator is same as the parameter. The variance of the random variables in the IID setup, individual variance, is fixed, and expectation also naturally is the same. So this is just a clear cut use of central limit theorem, that you have the statistic, you scale it by the mean, sorry, center it by the mean and scale it by the standard deviation, and it converges in uh, distribution to the normal, standard normal distribution. Now, this was easy. Like, this part, maybe you could recall some theorem also, but slightly tricky maybe this part. And when we look at this, we may think that this part in the denominator, it could go to this thing. uh, when we are talking about just this part, this could go to this thing. The reason being, we know that this thing, this estimator, the expectation is same as the parameter, and the variance, when we look at it, if we look at variance of p n hat, we will see that it goes to 0 because there is a scaling by n. So this thing converges in probability to this. And if I recall correctly, by the invariance property, this function, the function being fp equal to p1 minus p, this convergence holds, would imply that this would also hold. So we get an idea that this thing is going over here, but how can we make use of it? Simply by making fractional adjustments. So when we have a slightly complicated fraction, if we think around, there is a possibility of dividing it into, I mean, making it into a product of two fractions that are simple to deal with. This becomes a part of the central limit setup, and this part, the n and n's cancel, and we know that this quantity is going to this quantity. So this converges in distribution, this converges in probability by Slutsky's theorem. We do have this thing holding. Now, a pitfall that can happen is, whenever we think of central limit theorem and probability convergence, there can be confusion in how to understand them intuitively, and that may lead to errors. So when you think of central limit theorem, think of it as centering and then normalizing the that centered quantity by the standard deviation. That thing goes in distribution to the standard normal. But when we talk about probability convergence, we are just talking about the statistic or random variable itself, which is going to a fixed quantity, because fixed constant scalar, because its variance is going to 0. So it's like the complete variability is reducing, and it there is nothing random anymore, and it just goes to a constant. So these ideas are helpful, that can help us avoid pitfalls. Take care. Hare Krishna.